This is for Year 12 methods. It comes out of the Functions Application SAC Trial 9 question 4D. Part of the previous bit of the question had students working out what this particular shape was, and we knew that that had this particular rule. Okay, so I've set up my calculator. I've got my window exactly the same as this window here. So we can see I've gone from 0 to 12 and 0 to 4 on the y. And I've defined f of x to equal this function here. So that's going to give me f of x, and I'm going to draw f of x from 0 to 2 and end up with a graph that looks exactly like what that bit there is. So I've set this up the way that I want to. Okay, I'm interested in what the y-intercept is, and that's going to give me f of 0, and f of 0 should equal 32 on 9, so that up there is 32 on 9, which means that coordinate there is 6 and 32 on 9. Okay, I'd like to do this back one first. So to get this, it's a reflection of this. I'm told that it's a reflection over the line x equals 6. However, if I reflect this over the y-axis, that gives me this, and that's at -2. Then if I translate it 12 units to the right, that will put it at 10. So I want to replace x with -x because it's a reflection over the y. Then I want to replace x with x minus 12. So f of minus x minus 12 should give me this rule here. The negative first is the reflection over the y-axis, then x minus 12. So if I have f of minus, open a bracket, x minus 12, close bracket, that gives me this rule, which should be this rule, which means that r equals -4, s equals 9, and p equals 4. So if I consider that graph from 10 to 12, and I drag and drop it, I should get it at the other end. And I do. Okay, so I've got this bit and this bit. So I've ticked off P, R and S being those three. Beautiful. And I've got the first bit. Now, what am I doing here? I've got a sine function squared. Since a sine function is squared, I would normally have a sine curve that would go from 0, return to 0, and go up to 1, and then continue down like that. And then when you square it, it stays at 1. So B would have to equal 32 on 9 to get the maximum point to be 32 on 9. So B equals 32 on 9. This sine curve would be part of a sine curve that I'm only drawing the bit that was here from 0 to 0. So its period goes from 2 to 10. So that's 8, and I'd have another 8. Therefore the period equals 16. So that 2 pi on n equals 16, n equals pi on 8. And C has to equal 2 because I've moved across 2 units. So what I'm looking at? I'm looking at 32 on 9 sine squared of pi on 8 x minus 2 should be the rule that fits in there. So if I type that up, I've got 32 on 9. I'm going to open up a bracket and I'm going to square that bracket because I'm inside. I'm going to put my sign. So in here I have my sign, and inside the sign I'm going to have a fraction, and it will be pi over 8. And then I've got a bracket, and in there I've got x minus 2, and then I want to close that bracket. And if I open up my graphing window and I want to put a restriction, I want to give that x going from 2 to 10. And if I copy all of that, drag and drop, bingo, exactly as I expected. So therefore I've got b equals 32 on 9, n equals pi on 8, c equals 2 because there's already a negative there, b, n, c, done. So that's b and c, there's RSP.